Okay, we lost two problems. No problem. Okay, let's move on again to the whiteboard. Okay, let me try to erase the board and upload a new page. Dalida, it's okay. Let me try. Wait a second. Is that guy, I suppose. The last page. Make it zoom to see more clear. Okay, look. Number 19. Say 7 x squared plus 3x minus 4 equal to 0. Wow, easy. It's already this equation and standard. I determine directly ABC. A is 7, B is 3, and C is -4. Be careful with the sign, because the supposition of the original is supposed that everything is positive. When one particular example is negative, because the negative is the C value. This is minus B plus or minus the square root B squared minus 4AC divided by 2A. It's minus 3 plus or minus square root 3 squared minus 4 multiplication by 7 gets 8 multiplication by -4. Be careful with the sign. 2 times 7. Okay, when you focus it in the operation inside the radical, okay, that part, this is 9, it's obvious, but this is plus. Why? Because of minus, double minus. Entonces, make it 16 times 7 is 112. Plus 9 is 121. Oh, nice. Because I know the square root 121, remember the square root we are doing here is 11. Okay, super. So now we have minus 3 plus or minus 11 divided by 14. Okay, the multiplication 2 times 7. Okay, I like, separate into pieces. Minus 3 plus 11 over 14 and minus 3 minus 11 over 14. This is 8 over 14. I suppose we can reduce a little bit in lowest term. Divided by 2 is 4, divided by 2 is 7. Okay, this is my first solution. And my second solution is -14 over 14 and -1. We have two solutions, 4 over 7 and -1. Let me check it, see if everything is okay or no. Okay, 4 over 7 and -1. I guess so is B. It's B option. Boom. Any question, guys? Okay, this chapter is easy. So remember, this chapter is only the radical equation and the quadratic equation. Using the quadratic formula, immediately in few seconds or minutes, we start the review. We continue review. This is my idea. Friday, on Friday I will send the test number 5, and the test number 5 I collect next Monday. And next Monday we start the review for the final, the super review for the final, and the final will be next Wednesday. No, Friday. Oh, Wednesday, because Friday is the last day I need to turn in the grade. Friday. Okay, 20 is x squared equals 7 minus ax. Wow, completely disorganized equation. X squared plus AX minus I equal to 0. A is 1, B is 8, C is negative 7. The formula, I copy the formula all the time. Okay, now what should I do? Substitution, plugging in. B is 8 minus 8 minus 8 plus or minus square root A squared minus 4 times 1 times negative 7. Oh, be careful with the sign. Divided by 2 times 1. Okay, I go directly to the expression inside the radical. Expression inside the radical, that 1. I compute that. This is 64, right? Because A squared is 64 plus, because negative and negative, be careful with the sign, is 28. It's 28, no? It's 28, yeah, it's 28. That's 64 plus 28 is 92. 92, and a square root 92, unfortunately 92 is not perfect square, okay, but we can simplification, I suppose. How? Why not? That's all we are doing. 92 is even numbers, that's divisible by 2. 92 divided by 2 is 46. And 46 is divisible by 2, is 23. And that's it. Because with this couple of 2 represent 1, 2 outside the radical. So far we have minus 8 plus or minus 2, radical 23 divided by 2. In that case, you can split these two. It's negative 8 over 2 plus or minus 2 over 2 radical 23, que is equivalent to say negative 4, because negative 8 divided by 2 is negative 4. Okay, Noel. Plus or minus square root 23. Okay, so we have two solutions. Real solution, but irrational, because it's a square root 23, que es a prime number. Entonces negative 4, me see, oh, es D. ¿Es D o es? No. A ver, let me see. No. Es negative 4 plus or minus. Okay, es C. ¿Es C? Yeah, es C. Yes. Es C. Definitely, es C. Good, very good. Let's do the last one. 21. Okay, I'm doing fast or I'm doing well? You feel good or you feel bad? Opinion, come on.
A little too fast.
Too fast? I mean, too fast?
Yeah.
Okay, you lost something? You lost something?
Well, after computing the
Go ahead.
after computing the square root and stuff, I kind of missed out on the reduced things. Like
Okay, I understand. Okay, and this is specific example, Yamin. Okay, the only thing I did was, so you say that you understand the square root, but when you write here, I can see that these two you can split like that. Entonces negative A over 2 and negative 4, and 2 divided by 2 is 1, no? 1 gets invisible 1 here, and that's it. This is the part you don't see or no? Or before that?
yeah.
Do you see now?
Mm-hmm.
Okay, super. Another question?
No other questions.
Okay. Another student, no? Come on, guys. Everyone follow me. It's important, extremely important The application for the quadratic equation. This is the beginning of the college algebra. It's the next subject you take. Okay. Okay. It's super important. The professor. So you take with me, well, but in general, the professor que explain college algebra start again with quadratic equation. Okay, putting off the microphone, please. All right, let me see who. Oh, yeah. Yeah, me. Okay, there you go. Okay. The last one. Well, the last one in this package, you know, we start review. Is wow, it's weird. Let me try here. Is paréntesis 2x minus 1, x plus 1 equal 1. It's a quadratic equation also, but it's completely weird. You FOIL 2x squared, 2x positive minus x minus 1. I move this one to the other side like a minus 1 equals 0. Okay, FOIL and move everything to the left. You have 2x squared plus 1x because 2 minus 1 minus 2 equal to 0. Okay, let's do it. Then I determine that A is 2. Oh, here. A is 2, B is 1, and C is negative 2. Okay, using the quadratic formula is minus B plus or minus square root B squared minus 4AC divided by 2. Plugging in. B is 1. This is minus 1 plus or minus square root 1 squared minus 4. Multiplication by 2 is A. Multiplication by negative 2 is C. One more time. Be careful with the sign. 2 times A get 2. Okay, when you focus in the expression inside, we have 1 square of 1 plus, because we have negative and negative, plus something, plus 16, no? Because 2 times 2 is 4, 4 times 4 is 16, is 17. And a square root 17, you know, leave it like that, because 17 is prime number. And so far, we have negative 1 plus or minus square root 17 divided by 4. Okay, negative 1 plus or minus, okay, is SD option, obviously, is the option. Any question, guys? Okay. See, no question. Let's move on to the review. Review. Okay, by the way, I sent to you in this email the review. Okay. Let me try to upload review. Is call it review test 5. Test 5, but actually it's not test 5. It's a review, no? Test 5 I will send yesterday. Right. Okay, we come back to the radical equation. Number 1 is square root x plus 4 equal 10. Solve the radical equation with the one radical and checking your answer. Okay, let's do it. Remember, you isolate the radical expression. In this case, I move 10 minus 4 is 6. And now you square both sides. And when you square, the radical disappears at 36. Now the checking part. The checking part is plugging in that value into the original. Is square root 36 plus 4 should be, I claim that thing. It's obvious it's true because this is 6 plus 4 is 10. 10 equals 10. This statement is true. That means the solution is perfect. 36. Okay, the answer is this is 36. And checking was okay. Do you follow me? Radical equation. See, I try to summarize the step in the radical equation is: number 1, isolate the radical expression. Number 2, square both sides. Number 3 is, well, manipulation the equation in order to solve for x, or the variable. And finally, an important step, checking. Suppose number 2 is square root x minus 4 equal minus 10. Okay? Entonces you again isolate the radical. Minus 10 plus 4 is minus 6. Square both sides. It's the most important moment. X is equal to 36. Again, wow, it's the same. But I need to check. Substitution, 36 into the original equation, square root 36 minus 4 should be negative 10. And the square root 36 is 6. Is 6, and 6 minus 4 is 2, no negative 10. And this statement is completely false. That means that the solution is no good. So here, no solution. Okay, sometimes happen, guys, in the radical equation. No, not always. No. Seldom happen, but happen. You need to be aware for that situation. Okay. The checking is important. Peace. In college algebra, I prepare examples. Okay, we have 2 solutions, and one solution is good, and another solution is bad. But here, no. Here, was good, was bad. Okay, suppose number 3. Oh, number 3 is a little bit weird, because number 3 is cubic root. But it's the same, it's triangle. Look, cubic root x squared plus 11 equal 3. Well, okay, entonces now the radical expression is totally isolated, but the only thing you should do is now, let me copy again. It's cubic both sides, cubic, no square, because it's cubic root, so you cubic power both sides. Now we have x squared plus 11 without radical, and this is 27. It's 27 because 3 to the third power is 3 times 3 times 3, no? Entonces x squared is equal to 27 minus 11. And 27 minus 11 is 27 minus 11 is 16. Is 16. And square root 16. So this is look like quadratic. It's a combination. It's radical pero quadratic equation. But a quadratic equation in which b is 0. So you apply directly the square root method. Apply square root both sides. X is equal square root 16 is 4, and don't forget plus and minus. So we have 2 potential solutions, plus 4 and negative 4. Yeah, I need to check it one by one, see it's okay or not. I suppose okay, yes, both are okay or no, because look, you can check in both simultaneously, because it's cubic root. I need to prove the cubic root plus and minus 4 is square plus 11 should be 3. I need to prove this. I put double sign plus and minus because when you square become positive. That is 16. 16. This is 16 positive always, anytime. Plus 11 should be 3. And this is 27. And it's obvious que cubic root 27 is 3. 3 equals 3. Everything is okay. The solution is okay, but both solution is okay. Okay, so we have two solutions. The solution is -4 and +4. Okay, now let me see here. We have two solutions, x equals 4 and x equals -4. And let's check it was okay. Everyone follow me? Radical equation. Radical equation. In this case, I see one example. Okay, we have solution. Another example, we have no solution. The third example is have two solutions. Two solutions. Okay, moving on to next. Next page. Here. Okay. Okay, we continue. We continue radical equation. But in this case, let's see. Number 4 is square root 3x plus 1 minus x equal -3. Look like we are. Well. So you isolate. So the step 1 is isolate. So I move 3x plus 1. And I move minus x to the right hand side. To say it's like x positive -3. Okay, ready to square both sides. This allows me eliminate the radical, no radical anymore. But be careful because this equation do not contain radical. It's equivalent, but not 100% to the original. That is the reason it's mandatory checking in the radical equation. So you FOIL x minus 3 times itself. X times x squared. X times minus 3x is minus 3x. This and this together is minus 3x again. And this is plus 9. Okay, now it's ready. Well, first of all, combine like that. Why not? After the FOIL, not always, but frequently we combine lighter. Therefore, I copy that exactly the same. I move 3x and 1 to the right hand side, -3 and -1. You put 0 because we have nothing. And one more time we combine later. X squared minus 9x plus 8, no? Because 9 and 1 is 8. Okay. Entonces now, if you feel more comfortable, you write in that way. Okay, ready. This is ready to standard form, to solving by the way you prefer. You prefer by factorization or you prefer by quadratic formula. So what is my recommendation? My recommendation is you try by quadratic. By quadratic, no, by factorization. So when you will be able to see the combination, in this case, I suppose que es easier. Es easier, is two numbers can multiply, give me a. In this case, it's easy. I suppose que es easy, no? X is 8 and 1, because 8 times 1 is 8. 8 plus 1 is 9. And negative both, right? Remember, same sign, because this sign is positive, and both negative. And the solution is 8 and 1. Okay? Well, the question fly in the air is, maybe, Professor, we can do using quadratic formula? Of course. Let me prove. Let me try to do. Let me spend that time to show you that any quadratic equation we can solve it, well, by factorization. When you see the combination, okay, open the door. But when you don't see, okay, is the most frequently case, when you apply quadratic formula, A is 1, B is -9, and C is 8, okay? And you apply. Is 9, well, the formula, let me copy the formula, systematic. It's 9, double minus, look, it's 9 positive, plus or minus, square root 9 squared, or negative 9 squared, no? Minus 4, multiplication by 1, multiplication by 8. Divided everything by 2 times 1. Okay, we focus here on the expression inside the radical. And the expression inside the radical, we have 81 minus something, minus 32. Minus 32 is 81. Minus 32 is 49. I am happy because 49 is perfect square number. Square root 49 is 7. Okay, square root 49 is 7. And so we have 9 plus or minus 7 divided by 2. Okay, entonces 9 plus 7 over 2 is one solution, and 9 minus 7 over 2 is another solution. This is 16 over 2 is 8. This is 2 over 2 is 1. So 8 and 1. And we get the same answer. Advantage and disadvantage. Factorization is easy. However, it's weak. Not always we can use it. Quadratic formula is too long, but it's strong. Always we can find the solution. Well, but the good thing we have is we have calculator, no? Because too many calculations, the complicated formula. No, not complicated, but bueno, it's okay. Okay, entonces my recommendation is spend 2 seconds, only 2 seconds, to see if it's possible doing that way. I don't see, no problem. I switch it immediately to quadratic. And we finish, the answer is A and 1. No, why no? Because I need to check it. I need to check it in the original. I check it in the original. And the original. So original equation. Checking for A and 1. You have 2 expressions. Okay, I need to verification. 3 times A plus 1 minus 8. I am checking for 8. X equal 8. Replace equal minus 3. Okay, this is my first one. My second is square root 3 times 1 plus 1 minus 1 should be negative 3. Clean that. This is 24. Plus 1 is 25. And the square root 25 is 5. And 5 minus 8 should be negative 3. It's true. It's true. It's true. Therefore, negative 8 is a good solution. The second, 3 times 1 is 3. 3 plus 1 is 4. Square root 4 is 2. 2 minus 1 is equal to negative 3. Oh, it's false. Totally false. Totally false. Therefore, the solution x equal 1 is totally incorrect. So we have only one solution, que is 8. Okay, x equal 8. Okay, I did the checking part for this. Too long, right? Sorry. This is no elementary algebra. This is intermediate algebra. In few days, you start calling algebra. Okay. Any question, guy? Okay.
It's clear, Professor. Thank you.
Okay. Let's move on to this number 5. Number 5 looks like easy because number 5 is too radical. Entonces, what radical? Bueno, I isolate either one. Well, either. Entonces, you square both sides. Okay, you copy again, as always we are doing. You copy, but you square both sides. This is the square root. You square both sides. Entonces, in this specific example, both square root is clear simultaneously, but not always happen. You see in the number 6, no? So x plus 8 is equal to x. Now I try to solve in this linear equation, no? Que es 8 is equal to 3x minus x. 8 is equal to x divided by 2 is 4. But I need to check it. 4. The checking part is, I try to plug it in 4 here. Square root 4 plus 8 should be equal square root 3 times 4 is 12. It's 12. It's square root 12 is equal to square root 12. The subject is true, and the solution is perfect. In this case was easy, but not always. It's like that. In this case, completely different. Okay, I want to copy 6. In 6 we have a square root x minus 6 equal square root x plus 2 minus 4. Now I square both sides. Remember, I never touch the original because I don't want to transform the original. Waiting this expression for the checking part. This is waiting for the checking part. Okay. Now square. Square this and square this. Pero like one whole expression. No, it's not square both separate. No, it's crazy. It's x minus 6, and you foil. Because actually this is multiplication to binomial, like that. Radical x minus 4 times radical x plus 2. Radical times radical is the expression inside the radical, is x plus 2. Radical times negative 4 times radical x plus 2. Negative 4 times radical is exactly the same. And negative 4 and negative 4 is positive 16. Well, we combine like Turner. X minus 6 is equal. X stay alone. And 2 and 16 together is 18. This and this, lighter. And this is negative 8 radical x plus 2. Because remember how we manipulate the radical, no? When it's addition or subtraction, and the expression inside the radical is the same, we can combine. Negative 4 and negative 4, negative 8. Okay, now the next step is long, is isolate the second radical. Okay, let's do it. I move, so x minus 6 stay here, minus x. I move minus 18 is equal minus 8 radical x plus 2. Look at that. This is weird. This is cancel out. This is negative 24. And this is negative 8 square root x plus 2. Well, I suppose that one fantastic way, in this case, divided by negative 8 both sides. Because I take advantage that 24 is divisible by 8 and 3, positive, and radical x plus 2. And we have now elementary radical equation. You square both sides in order to eliminate the last radical. It's a 9 equal x plus 2. So for x, 9 minus 2 is 7. X equals 7. You need to check in this solution. Where? At the original. I never use it. Waiting for that moment. I need to verify the square root 7 minus 6 should be equal square root 7 plus 2 minus 4. Okay, 7 minus 6 is 1. Square root 1 is 1. 7 plus 3 is 9. Is 9. And the square root 9 is 3 minus 4. And 1 is not equal to negative 1. This is a completely false statement. Now this solution is completely wrong. 7 no good. And this equation have no solution. Definitely no solution. No solution. Yeah, I know because I did the checking bar. So we have a lot of combination, guys. One solution, no solution. Okay. You see? And you see it's important, the checking. The checking is extremely important. The checking is extremely important in the radical equation. It's mandatory. Okay. Okay, move on. Next page. Okay, there you go. It's this guy. This document. Okay, boom. Boom. Okay, we start now the quadratic equation. But what kind? Well, the equation is easy. Solve it without the quadratic formula. Let's use square root principle, square root method. The first is square root x squared, equal 25. In this case, I realize that the best way is apply the square root method. This is a square root method. Okay, this is x, and in the square root method, please don't forget square root 25 is 5, but it's plus or minus. We have two solutions. Two solutions. Entonces, here is x equal 5 and x equal negative 5. Two solutions. Okay, that was number 1. Number 2 is similar. It's k squared equal 11. Again, apply square root method. And the square root method, remember, is good, and the b is 0. We have no b. We have quadratic and constant, and b is missing. K is equal plus or minus square root 11. So it's positive square root 11, negative square root 11. That's the solution for the second one. Let me see number 3. Number 3 is exactly the same, except that we have another coefficient. This is b, no? B. The letter, the variable is b. B squared equal 81. Okay, so my recommendation is isolate b squared. So b squared is equal 81 divided by 16. Put it like a fraction, and you apply square root both sides. And b alone is equal to square root 81 divided by square root 16. In this case, both are perfect square number, 9 and 4. And don't forget plus or minus. Plus or minus. The answer is 9 over 4 positive and negative 9 over 4. Okay? Easy or complicated? You need to detecting, okay, you are working with the quadratic equation that is incomplete because b is missing. When this situation happens, this is easy. Don't complicate your life using the quadratic formula. No, of course no. Number 4 is similar, is negative 9 m squared, number 4, equal 81. Oh, similar. Entonces solve the quadratic, dice solve the quadratic equation using the square root property or method. Doesn't matter the name. In that case, you divide by negative 9 both sides. Entonces negative 9 both sides. And you have n squared is equal minus 81 over 9. And you apply square root here and square root here. and along is equal. Be careful. This is a square root, and inside we have a negative number. So immediately I know que es imaginary solution. I. And you manipulate square root 81 divided by square root 9. A square root. Oh no, okay. In this case, you can divide. Hello. It's easier doing the division. Okay, hello. It's obvious that it's easier, and that step, and put negative 9, no? Because 81 divided by 9 is negative. Entonces, the square root this is plus or minus 3i. We have two solutions, and the solutions are imaginary solution. It's 3i positive and minus 3i. How you detecting it's imaginary when you have negative inside the rank? Imaginary. No real number satisfy this condition. Okay. Number 5. Number 5 say 3x minus 2 squared minus 5 equal to 0. Well, in that case, also, you take advantage that somebody, not me, do the factorization of this trinomial. Entonces you can apply one more time the square root method or property, either way. Now you isolate that part, 3x minus 2 squared equal 5, and move 5 to the right hand side, and you apply square root. 3x minus 2 without square and square root is equal plus or minus radical 5. And you solve for x here. 3x is equal to plus or minus radical 5 divided by 3. Both sides. So x is equal to plus or minus radical 5 divided by 3. In that case, it's a real solution, but it's irrational solution. Okay, irrational is when you involve a square root of the primary number. So we have two solutions here: 2 plus radical 5 over 3 and 2 minus radical 5 over 3. Okay, not bad. Entonces ahí, when you see one element, one term que contain square, I take advantage. We can do it another way. Of course, we can do it another way. You foil here, you organize, maybe in standard form, you apply ABC, quadratic formula, pero no, it's too long. So I take advantage this square. Look, a number 6 is similar. Number 6, we have one term, is t plus 7, square equal negative 14. I take advantage this factorization. You apply square root both sides. T plus 7 is equal, wow, again we have a square root and a quantity or number inside is negative. So it's I plus or minus, don't forget plus or minus, don't forget the I, and square root 14. 14, we can simplification, I have no idea. 14 is even number, oh, no couple, leave it like that. So it's t is equal minus 7 plus or minus I square root 14. Boom. This is my final answer. Entonces minus 7 plus I square root 14 is one solution. And minus 7 minus I square root 14 is the second solution. Two solutions. Question. It's clear? So basically, in the review, we are doing the first part was a radical equation. And you see we have several possibilities. No solution, one solution, two solutions. However, in this, we practice a little bit the quadratic equation, but this incomplete. When the B is missing. This is important case, an easy case. Okay. Now, Opinion, guy. How do you feel? How do you feel? Edward. Opinion. Noel. Good. Okay. 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 Super. Let's move on to the next. The same package. Okay, it's this package. Next page. Next page. Here is with that. Bam. That one. Friday we continue doing the review. See, we finish the review. I have another package. Okay, so now, okay, this is a little bit different. Look, let me show you. Let me complete the square. This is important. Not too important, but it's important. In color algebra, it's super important. So let me explain in detail. Complete the square. Look. The idea is find the value of such that the expression is perfect square trinomial. I suppose that you remember very well. The perfect square trinomial. Okay, for example, this trinomial, x squared. This is a theoretical example. Minus 4x plus 4 is perfect square trinomial because the factorization, that guy, is x 2 because 2 times 2 is 4 and 2 plus 2 is 4 minus. Okay, basically the factorization is a two binomial. Okay, they are identical, twin brother. Now this is when this situation happens. This is perfect square trinomial. But we are doing Bauer. I need to discover, for example, number one example. In number one example, we have x squared minus ax plus something plus a. You see in red color, and this a is the magic number that create. Okay, this trinomial would be perfect square trinomial. So what is the rule? Well, the rule is you take b coefficients, because in our specific example is negative a. Or it's a, I don't care the negative. The negative is not important. You divide by 2, always divide by 2 and square. This is a formula to find the magic number. And our specific example is 8 divided by 2 square. 8 divided by 2 is 4. Square is 16. A is 16. You replace. No, A is 16, the magic number. Now let me check and see I'm doing well or no. Okay, when you are doing the factorization, this f 4 because 4 times 4 is 16 and 4 plus 4 is 8. Of course, both negative, and the factorization x minus 4. This is extra. The thing that they want in this example, okay, you determine A is 16. End the story. 16 is the magic number that convert this like a trinomial perfect square. Did you get that? Yeah. Entonces, who helped me in the second one? What do you think? What is the magic number in the second one? Okay,
I go for 14.
14. No, because you divide by 2 and square, Jasmine. Hey, Jasmine, no, David. So you divide by 2. Okay, what is B in number 2? What is B in number 2?
Oh no, I thought it was I'm sorry. I thought it was the same format as number 1, but it's not.
Okay.
I thought there was a common sense to it, but you can't treat that way.
Oh, okay. Okay, my question is, what is B in number 2? 7.
7.
Entonces the formula say divide by 2, 7 divided by 2 and square. is 49 because 7 squared over 4. Wow, it's weird, huh? And 49 over 4, we can simplification? No, leave it like that. Entonces, okay, entonces the answer is, professor, 49 over 4. Wait, let me check it just in case. Suppose x squared plus 7x plus 49 over 4. Let me prove that this is perfect square or no. I don't know if you remember very well where's the test can help me to prove that it's perfect square trinomial. You find the square root, this is x. You find the square root, this is 7 over 2. And you multiplication both and extra 2. Multiplication this guy, and 1 extra 2. Entonces, okay, when you multiply, you have 14x divided by 2 and 7x. It's exactly the same of the middle term. You see? Okay, but no. This is not completed. I need more thing. One more thing is what the factorization this guy. One of the factorization this guy is x, que es this. Is 7 over 2, que es this. And one sign in the middle positive, because this sign is positive and square. This is extra. This is extra. The thing that they want is find a value to create that trinomial like a perfect square. The answer is 7 over 4. Any question? Complete square. So, bueno, okay. Entonces you say, bueno, professor, what's the application of this? In what part is useful? Okay, it's useful for the solution of the quadratic equation. Let me show you now. This is another way, I never explained, I explain now. Another way to solving the quadratic equation by completed square. They want you solving this equation using completed square. Let me see number 3. Number 3 example say x squared minus 6x plus 1 equal to 0. We can use an ABC, of course, but no, in this case they want another way to get completed square. What is the organization of the completed square? The organization is, look, let me show you. You bring down x squared, you bring down minus 6. 1 no, 1 I move to the right hand side. And you introduce here the magic number. I put a box, not A, I put a box. I put the box. This magic number is a number that converts this trinomial like a perfect square. It's exactly the same formula we used before, b over 2 squared. Who help me? What's the value? In our specific example, b is 6. What is the value? What is the value? What is the value? Come on, help me. Come on, I need help.
The answer is 9.
9, very well. Where come from this 9?
It's
Go ahead.
I did it in my head, but somehow I got it to 9.
Okay. Well, your head worked perfectly. It's 6 divided by 2. You take b. B is 6. I don't care.
Right. That's right. 6 divided by 2 is 3, squared is 9.
Eso, bueno. Mucho bueno. 9. This is the magic number.
De nada.
Therefore, this trinomial is perfect square, and the factorization is x minus 3 squared. And the right hand side, we have 9 minus 1 is 8. And now we are ready to apply the square root method. Square root both sides. X minus 3 is equal plus or minus square root a. But I know that a is divisible by 2, get 4, 2. Wow, we have a couple 2. Go outside like a 1, 2 in the radical. So it's 2 radical 2. And stay inside the radical, this guy. Is this. Okay? Finally, we solve for x. X is equal to 3 plus or minus 2 radical 2. And it's the final answer. The final answer is 3 plus or minus 2 radical 2. So we have two solutions, 3 plus 2 radical 2 and 3 minus 2 radical 2. Okay, these solutions are real but are irrational because involve square root of the prime number get 2. It's irrational number. Okay, this is the idea for the completed square. Let's do one more or two more examples, 4 and 5, using completed square. And the test, don't worry for this. This is important, but not extremely important. You feel free to select the method that you want in the test. If you get the correct answer, you get the full credit. Okay, so some people don't like completed square. In college algebra, no. In college algebra, the test say mandatory doing by completed square. Some question, another no. Another completely free to select the method you want. Let's continue practice completed square. Number 4. Number 4 say x squared plus 2x plus 2. Remember the organization. The organization is x squared and 2x bring down. And you put a magic number. Que es, I don't know, es box. It's in the right hand side and move minus 2 plus another box. Does I need help? Any help? Any help to find the magic number? What's the magic number? It's easy. Divided by 2 and square. Who divided by 2? B, no? Come on, guys, help me.
2.
Come on. 2. No. What is B? 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 B? What is the value for the B?
2.
Oh, you divided by 2. 2 divided by 2 is?
1. I'm sorry.
And when you square? 1 square?
4.
No. 1 square is 1 times 1.
Oh, I thought you were squaring the 2 times 2. Okay.
It's 1. 1 here and 1 here. Okay, are you clear the idea or no? It's super easy. Divided by 2. And after square. Okay, sequence. Divided by 2 first and square secondly. Okay, now it's obvious. It's obvious. Okay, that part is, well, this is the idea for the magic, no? It's magic because convert this trinomial like a perfect square. Where come from this x? Square root this. Where come from this 1? Square root this. In the right hand side we have minus 1. Apply now. Square root both sides. X plus 1 without a square is equal plus or minus. Don't forget never plus or minus. When you make a decision, so at the last moment is apply the square root method. And this is I. Square root negative 1 is I by definition. So x is equal minus 1 plus or minus I. Okay, this is our final answer. 2 solutions, and in this case both are complex. One solution is negative 1 plus I. Another solution is negative 1 minus I. Boom. Boom. Bada boom, bada bang. Okay, number 4. Now number 5. Number 5. Number 5. Number 5 is, okay, I need help. The organization. X squared plus 16x plus minus 3, no? Minus 3, yeah, minus 3 equal to 0. I want to solve it using the new method, that is the completed square. Okay. And this is easy because leading coefficient is 1, so B. B, who's B? Well, what is the organization? The organization is bring down x squared and 16. I move 3. I put a magic number. Okay, I have no idea. Okay, entonces I ask myself, who's B? Who's B? In this example, who's B? Who's B? Hey, wake up. Are you there?
B is 16.
A 16, very well. And 16 divided by 2?
Is 4, and 4 squared is 16.
Oh, no. 16 divided by 2.
I'm sorry, 8.
8. And A squared?
64.
Absolutely perfect. 64. 62, 54 is our magic number. Okay, we are doing. Now I know that when you introduce artificially the magic number, that trinomial automatically, magically become like a perfect square trinomial. And the answer is x plus 8 squared. We come from 8, square root 64. In the right hand side, we have 67, no? 67. And apply square root both sides. Easy, I. X plus 8 is equal plus or minus square root 67. And 67 is a prime number. We cannot do anything. Thus the answer is minus 8 plus or minus square root 67. And the solution that we have in that problem is minus 8 plus square root 67 and minus 8 minus square root 67. Done. Final answer. Any question? Do you understand very well the complete square? Do you understand very well the complete square or no? A ver. Let me see. Do you understand very well the complete square? Dalida? Okay. Ese es amén. Edward, do you understand very well the complete square or no?
Understand.
Eso, bueno. Okay. Remember, in the test, you feel free to do by the method that you consider good for you. Not necessarily complete square. In Core Algebra, no. In Core Algebra is mandatory. Some problems do by complete square. Okay, where's the next page? I suppose it's this page. Okay, by the way, it's the last page. Wow. Okay, you see, I told you, okay, this is totally easy and short. How do you feel in this chapter? This chapter, the chapter, in my opinion, is extremely complicated, is the chapter 3, the factorization. The chapter 4, well, a little bit. Chapter 4, a little bit. This chapter is super easy. Okay, so in this chapter, in this last page, so when you finish this week, the class is over. On Friday, I bring another example. Okay, is apply the famous quadratic formula, and we have 3 examples of the quadratic equation, no? Pero solving using quadratic formula. Number 1, say 3x squared plus 2x minus 8. Nice. This is already present standard. I determine A is 3, B is 2, and C is negative 8. And using my famous quadratic formula. Okay. Substitution. B is 2 minus 2 plus and minus square root 2 squared minus 4 times 3 times negative 8. Be careful with the sign because we have double negative. 2 times 3. Okay, so I'm focusing in the expression inside. The expression inside is that one. This expression is 4. This is 4. And it's a plus because negative and negative together is positive. So basically is 12 times A. 96. And 96 plus 100, wow. And square root 110. Remember, you perform the operation inside, you perform B squared minus 4AC. It's the number one step. Number two is apply the square root, this big square root. Number three is you copy. It's a 10, no? Over 6. And you separate to see much better in two pieces. One plus, one using the plus sign, positive sign, and another piece using negative sign. Because actually I know that we have two solutions. Okay, 10 minus 2 is 8. Over 6, reduce and lower term, never leave it like that, is 4/3. And this is negative 12 divided by 2 is negative 6. Wow, amazing. We have two solutions, two real solutions, no imaginary, no complex, no nothing. 4/3 and negative 6. 4/3 and negative 6. And you see, in this equation, never you need to check it. No. Only in radical equations, in radical and rational. Okay, in rational, this is chapter 4, we need to keep. Okay, there are no coincidence with the restriction, no? But in this case, no, it's nice. Nice equation, always will have solution, or maybe real, or maybe complex, no? But we have always solution. Okay, any question, quadratic equation, you are boring to do that? But you have to practice, okay? So this is important. Some people go, I saw that some students don't, okay, it's your problem. It's not mandatory, I know. But take ridiculous grade in the test. The reason is because I suppose they are lazy and don't do the homework. So the homework, the idea for the homework is practice for the test, because the test is very, very similar to the homework. It's the thing you don't understand. So you are doing the homework, you practice the test. And also I give you extra point, okay? Okay. Now I determine A is 4, B is 5, and C is negative 5. Negative 1, sorry. The formula say minus B plus or minus square root B squared minus 4AC divided by 2A. Okay, this is my famous formula. Look at that. I saw here in the formula. Look at the formula. Well, plug it in. Negative 5 plus or minus square root 5 squared minus 4 times A 4 times C is negative 1. Again, be careful with the sign. Double minus 2 times 4. Okay. Again, focusing inside the expression. The expression inside the radical. You know, I repeat again the process because little by little, I reinforce it in your brain the idea how we manipulate that. No. Okay, this is 25. And this is plus, because negative and negative together, plus 16. And 25 plus 16 is 43, I guess. 25 plus 16, 41. And 41 is a prime number. 41 is a prime number. Square root 41 is a square root 41. We cannot do anything here. 41 is a square root 41. We cannot do anything. Now the answer is negative 5 plus or minus square root 41 divided by 8. I'll leave it like that. This is the answer. The answer is real, but irrational The answer is negative 5 plus square root 41 divided by 8 and negative 5 minus square root 41 divided by 8. Okay. Let's do in the last one, and that's it. And that's it. And Friday, I waited for you with the new problem of the quadratic equation and radical equation. I have another package. Okay, this was a review. But we have another section, so we take advantage of this section. The is x squared, x squared minus 10x plus 29 equal to 0. A is 1, B is negative 10, C is 29, positive. The formula minus B plus or minus square root B squared minus 4AC divided by 12. In our specific example, B is negative 10, those are double negative, and the formula becomes positive. Now square root negative 10 squared minus 4 multiplication by 1 and multiplication by 29. In this case, no, we have no double negative divided by 2 times 1. Again, we focus in the expression inside. Always, I create the mechanism. And you put in the enclosed in the blue color. Okay, because this is the first thing you should do. So it is 10 squared of 100. Is 100, yeah. I put in a calculator 4 times 1 is 4 times 29 is 160. And now subtraction. When you subtracting this guy, give me negative 16. And when you apply the square root negative 16 is I, imaginary, because negative quantity is square root positive 16, get 4. Actually 4I. So the result of that part is 4I, plus or minus, of course. So 10 plus or minus 4I divided by 2. I leave it like that? No, of course no, because it's possible to split this common denominator, 10 over 2, plus or minus 4I over 2. And it's a 5, 10 over 2 is 5, plus or minus 2I. Boom! And we have two complex solutions. And the complex solution is coming always in the couple of the conjugate plus or minus. So my answer for the last problem is 5 plus 2I and 5 minus 2I. Done. We finish. Super. We are the best. We finish early. And the reason that we finish early is because the semester is almost over. So I highly recommend everyone, please,